डॉक्टर रोहित सर ने ज्वाइन कर लिया है, आप उनको को होस्ट बनाइए। नमस्कार सर, गुड इवनिंग। महेश सर, गुड इवनिंग, नमस्कार। आप सुन पा रहे हैं मुझे?
Please talk to Mr. Yadav for me. It's on the phone.
रेवांगनी आप हैं?
यस सर।
ठीक है, डन डन डन।
He stopped now. Hello.
So you forgot me. Oh, sorry. I forgot
नमस्कार
you.
सर,
Sorry.
गुड इवनिंग।
Hello.
हाँ सर, सुन पा रहा हूँ सर।
Can my settings just 1 minute? Hello. Can you confirm somebody's I'm audible?
यस सर, यू आर ऑडिबल, यू आर विजिबल आल्सो सर।
Okay, great. That's I was to know.
नमस्कार, गुड इवनिंग।
Namaste. Good evening, sir. How are you? Please also let me know who are the audience and then how many, so I will do accordingly, and what is the time
PhD
as well.
scholars to प्रिंसिपल साइंटिस्ट।
Okay, that's great. So how much time you will provide me, sir? So I will do accordingly to
बिल्कुल
set
सर,
my-
वन हर 1 घंटा आराम से सर।
Okay. Ji sir, when you ready, allow me to share my screen.
आप
and
स्क्रीन
also-
शेयर कर दीजिए प्लीज, आप स्क्रीन शेयर कर दीजिए।
Okay, so hope I'm sharing my screen right now. 1 minute. It's audible? It's visible?
यस सर, विजिबल सर। पीपीटी मोड पे कर दीजिए आप।
No, I will do that, but first it's visible, then I will do on
हाँ,
PPT mode.
जी 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 जी। डॉक्टर रेवांगिनी
यस सर।
स्टार्ट करिए।
Okay, sir. Thank you, sir. The future of agriculture depends not only on producing in harmony with nature. Namaskar to one and all present here. I am Dr. Evangini Ranjha, Director HR and Academics, AgriMeet Foundation Bharat. And it gives me immense pleasure to welcome you all to another enriching session of ANKURAN 2026, International Summer School Cum Training Program. On behalf of AgriMeet Foundation Bharat, under the visionary leadership of our respected Chief Secretary and Course Director, Dr. Ankur Sharma sir, I extend a warm and heartfelt welcome to our distinguished keynote speaker, Dr. Mahesh Kumar Gathala sir. Dr. Gathala sir currently serves as the country representative of CIMMYT India. Born into a farming family and trained as a soil scientist, he has devoted over 25 years of advancing agricultural research, innovation, and sustainable development. Before taking on his current leadership role, he served as a science lead for Asia and North Africa in CIMMYT's Sustainable Agri-Food Systems program, where he played a crucial role in promoting climate resilient and resource efficient farming systems across the region. An internationally acclaimed researcher, Dr. Mahesh Sir is widely recognized for his pioneering contribution to regenerative agriculture, sustainable agriculture, conservation agriculture, and climate resilient farming systems. His work has empowered thousands of smallholder farmers through innovative mechanization, conservation based production technologies, capacity building, and science driven policy interventions. His scholarly accomplishments are truly exceptional. He has successfully contributed to more than 30 major international research projects, authored over 150 peer reviewed scientific papers, along with more than 300 scientific publications, and has actively contributed to high level national and international research and policy forums, leaving a lasting impact on global agricultural development. It is a matter of immense pride and inspiration to welcome a scientist whose research has significantly advanced the understanding of sustainable soil and crop management. His work beautifully demonstrates how science, innovation, and collaboration can build resilient agricultural systems for future generations. Dear participants, today's session is a rare opportunity to learn directly from one of the world's leading experts in sustainable agriculture. I encourage each one of you to actively engage, listen carefully, and make the most of this invaluable learning experience. With immense admiration and heartfelt respect, let us once again welcome our today's distinguished speaker, Dr. Mahesh Kumar sir. Sir, it is a great honor and privilege to have you with us at Ankuran 2026. We sincerely thank you for graciously accepting our invitation and sparing your valuable time to enlighten us. We eagerly look forward to your inspiring address. Sir, the virtual platform is all yours. Please.
So thank you very much for very nice introductions, which I don't know I'm deserve or not. But first of all, I highly, by my inner heart, thankful to the organizers, particularly uh, Amit and then following me for this continuously to push on that is on such a great platform. Please also let me know that if you need any clarification while we are presenting, I am flexible, though it's a 1 hour time, which is allow us to be kind of good time for discussions as well while presenting. So please raise your hands and somebody will allow to be clarify, or you can put it on chat, which I can see it on on that as well. So if this time then allow, that's because today I will more talk about on climate resilient agri-foods ecosystem for South Asia and how they will create through innovations and improved agronomic practices, because always we talk about the climate resilient breedings and genetic gains and all, but it's realized at globally at every platform that without agronomy we cannot achieve in genetic gains as well. So both are important. Agronomic or what we call that biophysical, and then genetic science is equally important, that it will contribute to 50-50%. Not only biophysical, even it's a socio-economic science also equally important to understand the social aspects of perceptions or adoptions or behavior change or markets or so many things that are also behind to be have this kind of ecosystems, and then to create more sustainable, more restoring, more environment friendly production systems in Asia and in South Asia particularly. So I will go that first. I will take. I'm sure everybody is about no summit. And the summit used to be work initially and established in 60s for breeding of maize and wheat to provide the germplasm. We know that Green Revolution, summit is always contributed significantly in our Indian food security for sustainability. And we remember Bollock Saab on that, how he brought the sacks of seeds from quite good shipments from Mexico to India directly. And we salute to our leadership, our science. During that time, they adopted those seeds and to resolve the issues of our food security during Green Revolution time. But with time, CIMMIT also evolved and transformed. So now CIMMIT not only works for maize and wheat, CIMIT works to provide the solution on system basis, on farming system basis, on production or food system basis. So from seed to plate. That includes social science, that include modeling, that include breeding, agronomy, mechanizations, so and so, and value chains and all. So CIMIT is working, on system basis that has evolved with time, and then we learn that's what is the, and which is came because of demand driven basis, because only genetic gain is not sufficient to be resolve our food security issues, and those secondary challenges came nowadays we are facing on soil health deteriorations, environmental degradation, to huge pressure on our groundwater aquifers, and then changing climate is one of our major challenge that we are facing. So CIMIT is evolving, and CIMIT is working to, closely to how to be changed. I think I'm sure in this group, uh, most of scientists and then people are aware about BISA. So BISA is stand for Bolog Institute of South Asia, which is the joint venture of Government of India of ICR and then CIMIT together. And this is established in 2011, and the mandate is again to be improve food, nutritional, livelihood security, and environmental rehabilitation in South Asia particularly. It is a great honor to BISA that Government of India in 3 states, they allocated big farms, innovation centers, which we call Ludhiana. I'm sure everybody, and then we welcome to visit all those research stations is kind of innovation centers. That's they allocated 500 acres in land in Ladowal. Then Jabalpur in Madhya Pradesh, which is again around 600 acres of land, which is in prime locations and very nice ecologies and potential systems. And then in Eastern India in Pusa, Bihar. And these research platforms are looking forward, particularly like Ludhiana is wheat systems, and then mechanization innovations, where Jabalpur is looking towards to move more on kind of regenerative kind of agricultures and residue management, and then Pusa is more on system optimizations and cropping system, diversifications and all. So CIMIT BISA in South Asia, driving value and growth, what we do, and we do it from translating laboratory research station to innovation for impact in farmers' field. So advanced breeding, as I was talking, so we do advanced breeding for climate resilient and system perspective. Most of our breeding is targeted to be biofortification and enrichment, and then how we can be make a more resource efficient of, breeding, targeted breeding for maize and wheat, particularly in India. Now we come to agronomy. So we will do data-driven food system research for sustainability, regeneration, restoration of soil health, and then how we can become to be more climate resilient. Demand-driven system science at scale that we generate with our partners, particularly ICR universities and then even private and manufacturers, particularly on that. And we establish a long-term experiments in different, on regenerative agriculture, not to be test single commodity, rather than provide the bundle of solutions together, bring together and test them. That's how we can be sustained for future, and how we can address the future problems of soil health, stagnation of our yields, and then how we will be deal to this changing climate and variability in that as well. And then we create network of agronomy innovations platforms in different regions and different ecologies through BISA or through partners, through ICR institutions or universities or state departments and private sector. Then we will do also strong diverse team in the regions that we have in India, particularly based in that we have breeders, we have agronomists, we have mechanization specialists, we have social scientists, we have crop modelers. So a lot of teams that we have a strong contribution that we want to put it in India. That's rather than repeating things, how we can put it additionality and complement to the existing ongoing programs of the national. Team willing and able to extend into emerging research areas like geography is different, and then strong collaboration that's we known for. CIMMET is known for directly working more towards the farmers, because that's our legacy from Borlaug time. We always believe to work more with directly farmers and participatory research, that we learn more from farmers, and then we understand also more their issues and problems, and then demand how we can be address those their challenges and all. I don't want to go in details. These are the major challenges that we are facing, and we know that because climate is a variability and change is a reality. We are facing more environmental stresses, including biotic and biotic, and particularly biotic is we are seeing those disease and pests and insects which were never seen before in the region, particularly in India and South Asia, like fall armyworms, like blast, wheat blast, like there are some weeds dominating. It was never be there, but now we are changing, facing those new challenges that we need to be dealing in future. Geopolitical instability, we know how we are in situation that because we are definitely for particularly energy, particularly for fertilizer, we heavily dependent on import, particularly from potassic and phosphorus fertilizers. So this is the opportunity how we will deal it to be how to make innovations, and then do more research that how we can use that indigenous materials through organominerals, crop waste, agriculture wastage, and then also new biologicals and biomes that to be resolved, and then how we can work on that. Demographic, we know population growth and aging and migrations and all that we know, and we are changing because if you see farmers, next generation, they don't want to be stay in farming because it's a profitability issues, it trust issues, is respect issues, is their contribution issues. So nobody want to be stay. So we need to be deal that as well, and how to make our agriculture production systems to be more attractive to engage and retain and sustain our population to be in agriculture. Technological innovation, sometimes too much technologies, farmers are confused, AI, so many apps. So how we can put kind of a key filter system, and that's proven technology go through only through that filter through a single information window, rather than going in several directions, and then farmers is getting confused, and then even policymakers are confused, even scientists are not sure how they will do, because we are sometimes biased, we want to put it that. And then definitely food, water, and energy system transformations, how we can make more resilient, more sustainable, and we are facing a lot of issues, particularly on water and soil health, and how to deal that, and environmental pollutions as well. So if you look at that, how we are, where we are, so critical environmental impacts, the total greenhouse gas emissions, 5% globally, that emissions 2.6, in that, but population crisis high, on that. But look at that in right side, because we are definitely facing all energy intensive, low efficiency, because heavily tillage based, we are doing agriculture, so that's also causing low efficiency and then heavy energy and all that as well. Population pressure, malnutritions we are facing, and the research advancement, particularly R&D. And unfortunately in India, we never focused on research and development on fertilizer for new products. We have a very strong research and development on application parts, on execution parts, but there is no to be manufacturing part for new products because of the incentives or subsidy issues or all. Our many private sector never focus on that, but now we realize that how is important, so we want to put it that as well. So again, nitrogen, 60% produced in 5 countries: China, India, Russia, and Saudi Arabia. But if you look at also, these 5 countries are the biggest importer, but these countries also the highest exporters. maximum export will come from these countries as well. So consumer and as well as manufacturing is happening in these countries as well. Definitely phosphorus, we are considering 5 countries in this, and potash is 80% in these 5 countries. Gaps, if you look at 60% fertilizer reduced in European and developed countries, but they increase 158% of their parcel factor or fertilizer use efficiency. In Asia, we increased to 30% in fertilizer use, but we decrease our or maintain or reduce our partial factor or fertilizer use efficiency. So this is the area where we need to work on that. So again, if you look at that, we also celebrate some of our achievements. If you look at that, and we never thought of that India can achieve, and there was a discussion in past that India ever achieved 100 million tons of wheat productions. But if you look at that, we already achieved 120 million productions. India was never thought that India will achieve 154 million tons of rice. Recently, it's a kind of too proud that maize is in 1 year is almost 12 million tons we produce extra. Last year, it was in 2024-25, it was 42 million point 5 tons. Now this year, we have a 54 million tons of maize production. So in 1 year, it's significant achievements. So that's the way we are achieving and will. So, but we are facing our 97 million hectares of lands are degraded because of intensive cultivations, faulty agronomic practices, overuse of chemicals, pesticide, insecticides. All these are the reasons that we are degrading because our soil organic carbon is deteriorating in most of the ecologies. Also, we lost of because of erosions our topsoils, and particularly like brick clinic and then prime agricultural land is to be converting to in different parts of that. And definitely our 35% still children and women, particularly 45%, they are either malnourished or anemic patients. So we need to be deal that how to be produced, because that our diet is changed, habits pattern is changed. We are moving towards to be mono dieting kind of pattern systems, in kind of more processed foods and all, and that are the reason that we need to be facing all these problems. If we look at that, how crop residue is damaging our environmental and ecosystems. If you look at that biodiversity, soil biodiversity is reduced because of soil burning, because soil temperature and most of fauna, macrofauna particularly is burned due to crop residue burning because it goes very high temperature. If soil microbiota also decrease, with this one, because we are removing more and then putting back is less, and natural predators that we used to be have, natural parasites and predators that also decreasing, decomposers particularly pests and parasites, all population is decreased. But if you look at that, pest and parasites population is increasing because of repetitious same cropping system, same management. That's our allows more population increase of these pests and parasitic and disease on that. If you look at other sides, significant populations, and there are several documentations on that, pollinators particularly like honeybees, butterflies, and all population is decreasing. Growth of microbial population is decreasing. If you see reproduction and diversity particularly of soils, biomes are also decreasing. So if you look at that, crop yields are either going down and it will be challenged, and definitely system resiliency is reducing in that way. So that's we are facing on challenges on that. So how to we deal that as well? If you want to go for detail in this paper, it's well documented how it's affecting the environment. So this is the overall concept for future, how we'll do, because we are facing challenges. One way is more biotic and biotic stresses, more climate variability. Another way, because input cost particularly supply chain is getting more and more expensive. So challenges are how we can be make our system more sustainable, but with less, and how we can get more outputs. That's the challenge, and that's we have to be do in future. So, and these are doable. If you look at that, I put my these slides, and if you look at that, how we can be reduce the ill effects from the system, which is major is excessive tillage or intensive tillage. So how we can move towards to be conservation agriculture based management to reduce tillage or regenerative agriculture practices. In that system on that level, then we can be handle at some extent. But sometimes conservation agriculture or regenerative agriculture people understand is only no till not. But we need to be redefine the recommendations and efficient use of external inputs, particular natural resources, as well as input means it's like input supplies of fertilizer, energy, and fuel and water as well. Because we cannot be recommend same as we do in traditional system as well. So that has to be redefined, fine tuned in different agroecological zones, and then particularly field to field on those basis. It's very clear to me and all farmers, and it will tell to farmer that okay, if you will do this regenerative agriculture, organic farming, or natural farming, or conservation agriculture, or whatever improved agronomy, it will improve your soil after 5 years for your next generation. It will maybe reduce some yield, but it will give you advantage in future on your water. Forget it, farmer never will adopt it. So it must be two criteria. It that options or solutions that we are providing to the farmers must be economical. It should not be compromised with the existing yield, and it should be viable with them for farmers. Not only that, because whatever solutions we provide, that solution should be also fit in their farming system, like particular crop varieties, crops, maybe cropping system. They are not fitting well in their livestock or poultry or fisheries or maybe other different, or maybe particular variety which we are giving to farmers is taking 10 days extra and giving 10% higher yield, but is impacting next crop and reducing the yield of 20 to 25% is not going to work. So we need to be provide the solution that which fit within their farming system and in their system as well. If we do that, definitely will improve our system, resilience, and then kind of more sustainable. We will provide more water and energy for future. Definitely clean environment. We can reduce burning and all, and conserve our biodiversity and restore our soil health. That's the mechanism needs to be used kind of in that. If you will do, definitely will be also achieve our SDGs goals, but also provide to more stronger our country and region in that, and more peaceful, because it's that. This is one of the examples I always put it. This is from NRM. And I remember when we started this conservation, leisure land leveling recommendation. And I remember in 2003 and 4, first unit we directly put to at farmers field. Before that, there was some research in India on leisure land leveling, but it was limited within that research farm. It's limited only for the research. But when we put this leisure leveler, unit in Western UP, and I know the farmer name is Pramod Tyagiji in Hapur, in Bulandshahr district. It was in Bulandshahr before, now in Hapur district. And it was heavily criticized by human engineers, human policymakers, human scientists. That's how this sophisticated unit can work in India and at farmers field, how they will deal it. But farmers see the benefit. If you look at now, the Haryana, Punjab, and Western UP, almost 95% of agricultural lands are leisure land leveled. If you look at more than 20 million hectare of agricultural lands are covered under laser leveling in India. It's provide a huge amount of opportunities and employment to that. Almost more than 100,000 units are working individually in India, particularly now. India become from import country to now export country, and it saves a huge amount of irrigation water. If you look at it annually, it's a huge saving of irrigation water. So there is a lot of economic gains on that. It's increase also 5 to 10% of yield of the system level. It saves electricity, it saves energy, and there are many other benefits. And more than 100 manufacturers are working in India around there now. This technology is moving slowly from northwest India to central India to south India, as well as in eastern India and west India. And you will see that's how they are slowly advancing in adoption of that laser land leveling. So this is one example. That's how we can be make on impact on technology, but that technology have some advantage to the farmers. If we look at also, we were working on conservation agriculture based, and regenerative agriculture based. And I remember also when we started working on direct seeded rice and no-till wheat and other, on that. And it was a lot of reservations, particularly on direct seeded rice. But now direct seeded rice is taking as a priority in India by several states because of labor, because of water, because of soil health issues and all. And if you look at it's moving, but if you look at conservation agriculture, particularly no-till in wheat, maize, and other crops, is advancing. But look at the advantage, because we have a long-term experiment, not only in a small plot. Each plot is having kind of like a 2000, which is half an acre plot, and which is in Karnal at CSSRI, in Ludhiana, in Bisa farm, in ICRMR, in Eastern India, in Bisa and RPCAU. And if you look at all these platforms are either maintained from last 20-25 years, and there is no single tillage was repeated. So it's maintained from last 20 years without tillage. But if you look at benefits on soil health aspect and all, it's increased soil system yields up to 30%. It's decreased the fertilizer used by 27%. It's decreased also use of fuel, particularly for tillage, by 50%, and it's reduced water by up to 85%. So we did what as well? We put it innovations like subsurface irrigations for fertigation and irrigation to provide only root zones as well. In rice, wheat, and in different cropping systems as well. It's also diversified as well. And it's definitely reduced labor. But economical benefits is reduced up to 50% of greenhouse gas emissions, is doubled organic carbon in 15 years. It's increased like around 100% of populations of soil microbial, as well as other orthopods. If we go right now in canal sites, you will see millions and millions of earthworms are coming from the plots. And if it will be really to see those kind of difference between farmers practice versus this, it's definitely increase in 33% in yield gain on system perspective, and increase up to almost double the income of the farmers. And if you move that, it will be address the issue of One Health, climate resiliency, Atmanirbhar Bharat, and food and nutrition security on that as well. It improves soil physical and biological and chemical properties too as well. So these are the examples of the several experiments that we have. We compiled it, and this is the outcome of that as well from many years. This is again an achievement that we get because several schemes and then options came for crop residue burning. But it is clear that residue burning solution will come from in situ. Ex situ we are not against, but ex situ is provide only limited kind of amount and area that we can address. But most of solution will come from the field itself. And in that, there is a paper that is showing clearly that happy seeder is the most viable options that will be restore your soil health but also improve that. But if it look it also in recent year and last year, Haryana and Punjab almost address the issues of this crop residue burning. Haryana is claiming 90% events. I'm not saying amount, but 90% of crop residue burning events and sport is reduced. Similarly, in Punjab, also up to 95%. So I would say not 95, even there is a significant reduction. I think it's a really significant achievement for that. But unfortunately, Haryana, Punjab is dealing, but Western UP in sugarcane trash and an MP and Gujarat and even Maharashtra and even Eastern UP. So now you will not surprise Madhya Pradesh is the highest crop residue burning state at the moment compared to Haryana and Punjab. So this is going in different, and this is highly linked with what? Mechanization, particularly combined harvesting. Where is combined harvesting is going, this burning is also coming, and this is unfortunate. So we need to be look at this, how to be addressing those issues. And not only like rice and wheat residue in MP, all crop residues now they are burning for maize, even for soybean, even for wheat and rice, and then all kind of residues they are started to burning. So we need to be work how to be stop that, because it it will be continue to working on burning. We will definitely will face more challenges on our soil health. This is the capture that looking that and looking this Atmanirbhar Bharat, and we organize in the leadership of our honorable secretary of there and ICRDG as a harvest day to invite all media that how this regenerative agriculture or conservation agriculture can address that we are facing the issues of fertilizer, soil health, water, environment. If we adopt this right technology, it can be address all these concerns, and India can be a self-reliance on fertilizers, on we can save water and all. So this is heavily captured by media and all, and I think we need to be focused on that as well. We also explore that kind of see the indicators in different and different crop diversifications options in northwest India particularly, as well as eastern India, and look at that maize wheat mung bean and maize mustard mung bean is the best option is coming in northwest India to replace rice wheat system, and that will allow more. But why is not happening? Because from last 6 decades, if you look at that, all enabling system around our processing industries, supply chain, farmer ecosystem like equipments and all, procurement, markets is evolved and transformed around rice wheat system. So even that will provide farmers some extent to be kind of like incentives is not sufficient, because it's require more infrastructure, more markets, assurance of price and all. Then really farmer is thinking, but it's still increasing, and it's that. So again, unfortunate that we started to be kind of demonstrate maize in Kharif in monsoon Haryana, Punjab, but instead of Kharif, now they move to in spring, which is also have a kind of over pressure now on our aquifers on groundwater. But still, we can do better in that. Even farmers adopting in spring, we need to work more on better water management through drip irrigations or something like subsurface irrigations, drought tolerant maize varieties or hybrids, or maybe kind of different at stage of different cropping systems also. In that way we can address those issues as well. This is again example that if we replace rice with maize, we can save at least 30 days window to handle the crop residues and all. It gives more yields, it gives less production cost, it provide more income, and definitely reduce at least like almost how many times? It's three times of global warming potential, and eightfold decrease the irrigation requirement. So these are the lessons that we need to be, but we need to be promoting together in enabling system, bringing policies, infrastructure, and everything in one place. This is Eastern India, and in Eastern India, either there are two major cropping system: rice system and rice wheat system. Both are more and less in 6 million hectare in Eastern Gangetic Plain zones, particularly in Eastern India and in Bangladesh and Nepal. And if you look at that, we tried several cropping systems. Rice wheat and rice systems are not profitable, not comparable, not sustainable in that region. But if we diversified that system with maize, so rice maize system, rice lentil system, or intensification with rice wheat through jute or mung bean or through other interventions, really we can achieve very high profitability, productivity, and then give additional, I would say, green revolution, and we can create another food wall in the eastern ecologies to be optimization of the system, particularly because boro rice is causing a lot of problems in that region, because again withdrawing and heavy energy and input intensive too as well. But if we replace boro rice with maize, we can reduce like tenfold of irrigations, and then that fallow land, because of lack of irrigation infrastructure, that can be converted to cropland by replacing maize, because same water can be increase the area, because boro rice required 20 irrigation, maize required 4 irrigations. So 4 times area can be used for same water amount. So that way we can be do. Maize is more potential, high yield as compared to boro rice in that region too as well. This is again when we to talk about fertilizer management. How we move from an approach that we can be take, because most of our recommendation at the base of ad hoc basis or blanket recommendations on crop or as particular regions kind of things. But if we move from that to be kind of fertilizers that integrate with decision support tools based on soil testing, management, production system, cropping systems, and then we can improve our efficiency. If we move further on field basis recommendations on plant response using digitizations, also using these new products of slow release fertilizers, organominerals, biomes, biologicals, I think we can really address a lot of issues that we are facing at the moment of shortage of fertilizer and nutrients, particularly that we can be addressed. If we look at, and this is the example of Bihar, and we did a lot of data collections through KVKs, and we found, and you will not surprise, now Eastern India is using more nitrogen fertilizer than Northwest India in most of the crops. And we look at that, we found also, if you look at red spots, blue spots and all, and we found that there are areas where they are using overdose of nitrogen, where there are areas farmers using low use of nitrogen. If we do optimize both, where we can reduce farmers are using overdose and then increase or kind of dose where farmers are using over lower use of nitrogen fertilizer or other fertilizers, we can really save and increase our productivity and production in those regions as well. This is again climate smart villages that we are working with BISA and with for South Asia with ICAR, particularly CRIDA and other national institutions. And this is a kind of providing climate smart agriculture and villages, which is adopted heavily by the farmers, and where we are linking not only with mitigations as well adaptation strategies and forecast as well. And that's where really that's our working. So those villages is adopted all CSV approach. They improve their resiliency, their productivity, their system resiliency, as well as also kind of production and their income as well too as well. This is Akasa. Akasa is an atlas for climate adaptations for South Asia, and this is a almanac, and you can go through that, where we are kind of assessing the climate risk assessment, 5 by 5 grids, 25 square meter area, and then linked with that climate risk assessment with the mitigations and recommendations strategies to kind of what we call that mitigate of those risk assessment as well. So at the moment you go on the website, you will find there are 5 to 6 crops, that's rice, wheat, maize, millets, barley, pulses, oilseed potato, and then 7 livestock species, particularly cattle, buffalo, sheep and goat and chicken. And they provide location specific validated kind of technological interventions and mitigation strategies to the farmers. If you want more information on this, you can go through that. Then resilient, genetically diverse and inclusive seed systems. So BISA is really creating a seed systems particularly for climate resilient biofortified high yielding wheat varieties that we are doing, we are tracking, and that's we are trying to be inclusive and providing through seed villages, linking with that how we can be provide more and more of this newly released variety. Good is thing that in wheat production, that seed replacement within 5 years, which can be count very good, and that's why wheat productivity is going, and then it's really very good and more resilient to that as well, despite the changing climate and all. This is management of acid soils for sustainable intensification in farmers in Eastern Magnetic Plain particularly. And if you look at that, we have a dedicated research around R&D on salinity and sodicity. But if you look at in last many years, soil acidity is increasing, and there is no dedicated much efforts is made on to correction on soil acidic management. And because of low use efficiency, particularly nitrogen fertilizer and phosphatic fertilizer, because of soil acidity, farmers are putting more, and which is contributing because we are applying in either ammonical or amide form, which is further aggravating the problems of soil acidity. And if you look at in past year, only 20%, soil acidity problems will increase, area is increased in India. If you look at soil maps from NBBS and LUP recently launched, that soil acidic area in India is increased significantly. And this is causing problem of low productivity in particularly eastern ecologies of India, like West Bengal and on upwards of northeast regions, Odisha, Jharkhand, and then some parts of Andhra and other regions too as well. This is new, and I'm sure you heard about biological inhibition of nitrogen, which is called BNI, biological nitrogen inhibitions. This is a kind of biotype which came, and the new breeding is efforts are going on. And if you that is from wild is sergoline and branchy. These are two species that found they somehow kept that in root zones that's more in ammonical form, nitrogen to having a slow mineralizations. And if that breeding is in advanced stage, we are hoping that varieties of BNI will come in that. If those variety will come and it will be adopted with farmers, I think we will be able to reduce by 25% of nitrogen use. So that's why we are targeting. Now these efforts are ongoing for wheat, for sorghum particularly, but we are also starting work soon on maize and then other crops as well. So those targeted bidding is in progress. This will be help as well. Carbon credits, I don't want to, maybe you heard a lot on that, I don't want, but capacity building is very, very important. And in that, Simit and BISA with ICR, we do advanced course on regenerative agriculture for Asia. This is not like theoretical, which is highly hands-on training, where we invited from different countries. If you look at that, more than 20 countries is benefited since 2020 10, and more than 240 participants and researchers, young people will join from Asia and North Africa. This is very important training, and we will do again in this year, particularly in end of October and November, and we will welcome. Though this is very expensive, but it's very productive, very useful, very knowledgeable, and we'll invite all of you. We need to be also work on that to be strengthened, to involve our policymakers, to make awareness, to keeping them in from the beginning on regenerative agriculture, on long-term trials, all those kind of things is very, very important as well. You see that's how they are. Conservation agriculture is important. If you look at that right and left, date of sowing is same. Both fields are leveled side by side. In one day, in 2021 something, I think there was a rain 72 in 1 day. One side is conservation agriculture, another side is conventional. In conservation agriculture, on next day or within few hours, water is disappear. But here water is still ponded, so crop is more waterlogged, and then crop is be facing more issues in that situation. And particularly nowadays, because of this rotavator issues, rotavator is making more compacted soils, so our soils are becoming more and more impermeable. And if you see farmers, those farmers are adopting rotavators. When they give first irrigation, their crop convert immediately as a yellowing, and then farmers feel that, oh, yellowing is happening because of nitrogen. But that yellowing is not because of nitrogen, because of waterlogging, and more moisture, more anaerobic situation is happening in the field. So farmers apply more nitrogen to overcome of that problem. So that's why farmers is overuse of similar example. So thank you. I think we have time to be 15 minutes to discussions, and I am happy to give questions and answer. Thank you very much. Over
Thank
to
you so much, sir, for such a wonderful and insightful presentation. Now we'll have doubt clearing session. Dear participant, this is now a perfect opportunity to interact directly with our esteemed speaker. If you have any questions, doubt, or would like to seek further clarification on today's topic, we warmly encourage you to ask. You may unmute yourself to ask your question directly. Alternatively, if you prefer, you can type your question in the chat box. Please don't miss this opportunity to learn from such a distinguished expert.
I think somebody has to be allowed to.
The chat box is open for all the participants.
I will check that. I will just stopping my, and then I will go in chat as well if there are any questions, or we can take some questions if we can allow also directly as well. If not,
Sir, I believe your lecture was so comprehensive and self-explanatory that the participants are unable to come up with the
I
question.
can see some message.
Yes, sir. Yes, sir. There is a
Okay.
question.
Okay.
Sir, there is a question. I am at a water scarcity region, Nandurbar tribal district of Maharashtra. I want to take seed production. Which crop should I prefer?
I think this is thank you and asking these wonderful questions. It depends. Uh, but if you are looking in that, I would be prefer to be more focused on millets and legumes in that situations. Even you can also look it to be produce seed on cotton as well, but you need to be work with that technologies of how you need to be work on that. But definitely you can produce nicely seed production of particularly pigeon pea, legumes, and millets, which will be provide more opportunities and suitable for your areas, particularly in drought-prone areas of Maharashtra.
Thank you, sir. So we have another question. Is rotavator application is necessary after every primary tillage?
And thank you very much. But why we need to be use rotavator? Rotavator is killing to our soil because if you look at that rotavator, how many you know gauge in rotavator, how many plates in one gauge is six plates, right? Six blades. And then rotavator speed is around 300 rpm. 300 multiplied by 6, how much? 1800. And our blades are L shaped. Assume if we beat our soil and cut our soil 1 minute in 1800 times, what you will expect from the soil compaction. And not only that, that the soil aggregation and structure is built from many years. And then when you run the rotavator, it will kills immediately, destroy your soil structure. Unfortunately, when farmers are using rotavator for puddling and churning your soil, distracting your all structure and aggregation, and exposing your all carbon to be burned to expose, and that's why we are facing problem of soil health. So if you will be continue to using rotavator in continuous 5 to 10 years, then it will become another recommendation. Oh, we need to be do subsoiling, we need to be add more carbon, we need to be remove these and that. So this is again business led oriented technologies. I sorry, but I'm not fan of rotavator at all, and I will not recommend rotavator to use in the field.
Thank you, sir, for such a clear and comprehensive explanation. And we have another question. And the question is, how does El Nino and La Nina effect influences Indian monsoon and agricultural productivity?
Definitely, it's already reports are coming that's at least 100,000 area of this season crops are not planted, but I'm looking even more because of this El Nino and on effects. Not only that, you will see also because the rainfall distribution and intensity is also creating a problem. I don't know what will be happen in future. We need to be that. So that's why our regenerative agriculture or conservation agriculture based technologies that can be create more resilience is very important. And maybe this El Nino will provide in some ecologies is even advantage, but in some ecologies maybe in negative. So it's difficult to answer at that moment, but definitely we'll face the challenges of this El Nino in our agriculture, particularly in this season.
Okay, sir. So we have another question. What is the scope of carbon credits in Indian conditions? With respect to small and marginal farmers, how to take advantage of carbon credits?
So again, there are issues in this carbon credit, but now reality is happening. And some of the projects it's proved, Grow Indico, Bara, and then Bayer, and then there are other projects that they proved and they gave some incentives to the farmers. And I'm looking forward it will be a opportunity for small and big farmers and how to be validate and how to be adopt the protocols of MRV. I think there is opportunity for to trap this kind of market, carbon markets in India for smallholder farmers, to give them incentivized to be for crop diversification, for adopting the right technologies, and then environmental friendly technologies, soil restoring kind of sustainable technologies, improved agronomic innovations and all. I think we should be looking forward to that. It's possible, and I think it will come. But not only these carbon markets, we should be also looking to be reward or allocate or kind of giving a green cards to the farmers, and that could come from the government, I think, to be incentive based. So those farmers are using good technologies, they should be rewarded with green credits. Those farmers are using bad technologies which are not sustainable, not recommendable, they should be not rewarded with green credits as well. So we need to be work in future how it can be kind of so we need to be moved to be subsidized ways to be incentivize on mode and piloted as well in agriculture.
Thank you, sir, for patiently addressing all the questions. And I believe that was our last question of the session. So let's conclude the session. As we come to the end of today's enlightening session, it is my privilege to express our heartfelt gratitude to our esteemed speaker, Dr. Mahesh sir, for delivering such an insightful and inspiring lecture. Sir, your profound knowledge, rich international experience, and practical perspectives on regenerative agriculture, conservation agriculture, and climate-resilient farming systems have greatly enriched all of us. Your sessions have not only broadened our understanding, but have also motivated us to think innovatively about the future of sustainable agriculture. On behalf of AgriMeet Foundation and the entire organizing team, I extend our sincere thanks for graciously accepting our invitation and sharing your valuable expertise with us. We are truly honored to have hosted a globally renowned scientist like you. I would also thank all the participants for their enthusiastic participation and thought-provoking interactions. We look forward to welcoming you all to our next enriching session of ANKURAN 2026. Thank you, sir. Thank you, everyone, and have a wonderful evening ahead.
Thank you very much, Dr. Anjana, again to be giving these opportunities, and I hope I justify these invitations, and hope all audience enjoy this. But again, I will request to everybody, please reach me out if you have any questions. My email I'm putting on chat is m.gathala@CGIAR. I would be happy to answer if you have any clarifications and questions from me. Thank you very much.
Thank you, Raksha. Thank you so much.
Big opportunity. Thank you, Ankurji, for inviting me and then pushing me. I was not sure, but because of your inspirations and then giving and pushing, I make this availability. Thank you very much.
Thank you so much. Jai Shri Ram. Namaskar.
Jai Shri Ram. Thank you. Thank you very much.